So thank you all so much for coming out to today's partners session. My name is Kristina, and I'm an application security engineer here at Shopify. And today I'll be talking about web security fundamentals. So again, as I said, my name is Kristina Balaam. If you want to find me after the webinar for any questions or follow-up comments or anything like that, I'm on the internet in a whole bunch of different places, and you can see them all listed right here on this slide. And if you'd like to see the slides themselves, again, they're going to be part of the recorded webinar, but if you'd like to just access them independently, you can reach them at this link. They're basically just uploaded to GitHub's slide sharing application, and there's everything you need is right on there. Great, so we're just gonna kind of go through a bit of an outline on what this webinar is gonna cover. And I really wanna emphasize this is very much a crash course in web security fundamentals. There is so much to learn and understand and practice with web security. And this is really just going to be very much a crash course in some of the basic vulnerabilities we see a lot of and how to prevent them. So the first thing we're going to talk about is why should we care? Why should we care about making sure that our application is totally secure, or at least as secure as we can make it, especially for those of us who, may come from a background of working for smaller companies or agencies. Why do we care if someone could potentially hack our web application if it's a brochure site and we're not actually collecting user data? Why do we need to care about this stuff? Then we're going to jump into just an overview of 4 main types of attack vectors in the web sphere. So the first thing we're going to talk about is cross-site scripting, and then we're going to chat about client state manipulation, cross-site request forgery, and SQL injection. And for each of these, we're going to talk about what these attacks actually involve and different ways they can be performed. We're going to see a demo of actually, performing one of these attacks in a very safe environment on a vulnerable web app, and then we're going to chat about how to prevent them. We're also going to see real-life examples of these happening out in the wild, and they all are accompanied by reports that you can read more about in your time after the webinar. And then finally, we're going to talk briefly about how to keep learning. Now, as I've said a bunch of times, this is a very important topic that requires kind of a lot of practice, actually. And the more time you spend improving your knowledge of web security and learning from others' mistakes and learning from your own mistakes, the better you can get. So I've listed some resources, some really great books, some great courses, and we're going to go through those and see how you can basically keep improving after you've learned the basics today. Short answer, yes. Security breaches don't just happen to banks and large corporations. And I've heard so many developers say that they don't need to worry about some security issue because they're not a target. And at one point in my life, I used to think about this as well. But the truth is, you don't ever really know whether you're a target. Even if your site isn't accepting usernames or passwords, and it's just a brochure site, data in general is still a huge asset to hackers nowadays. Small agencies also, in particular, tend to take a lot of junior developers right out of college or university or bootcamp programs. And I know from experience that a lot of those programs don't necessarily focus on security education. In my computer science degree, we had a very hands-on program, which was great. We wrote a lot of code. But really, our discussion of web and software security kind of boiled down to theoretical encryption algorithms. And that just wasn't really enough to go out into the workplace and know that the code you're writing is super secure. So for those of you who are listening in who may not be developers, but maybe managers, and even for those of you listening in who are developers and might take on a lead or like a VP of engineering role, really invest in your developers' education. It doesn't mean that they need to go back to school and do like a full-blown master's degree in cybersecurity, but there are some really wonderful books. There are some great, relatively inexpensive courses on the internet. There are also some great free courses. Coursera has some that are offered by universities or other post-secondary education institutions. And they can be a great resource for developers to really just brush up on the knowledge that they should have learned in school and maybe didn't. What's really interesting is that IBM recently conducted a study outlining the odds and costs of data breaches to organizations of all sizes, and this was done in 2017, so it's current for this year. What's really interesting about this is this report showed that as we progress, as a society really connected on the internet, the cost to organizations is actually decreasing. So the cost organizations have to pay when they do experience a data breach is decreasing. And they believe this is likely because more organizations are taking preventative measures and employing incident response teams that can contain attacks more easily. But what's also really interesting and kind of scary is that the average size of data being affected is increasing. The study also outlined that the odds of an organization experiencing a data breach is just 1 in 4. And these aren't, Fortune 500 or publicly traded tech organizations that have this potential for data breach. This is really just any tech organization or a company that exists on the web. And I think it's really important for us to discuss security because security really builds trust with your customers. For us at Shopify, our merchants know that they're on a secure platform, and by ensuring that the platform we're providing is secure, we build trust with those people. And in the same way, third-party app developers, provide trust by making sure that their applications are secure and that the data that merchants may give you access to won't be used in any sort of malicious way and won't be available on the internet somewhere, and hackers can't come in and essentially take advantage of that data. As we've talked about a little bit already, in the world of e-commerce, data is really valuable. So, it's not just making sure that credit card numbers are protected. That's fairly obvious. But even the data surrounding the number of sales for merchants and the number of customers, that is also very, very valuable information, and it can be used in a malicious kind of way by some sort of competing merchant or, angry customer or whatever. So really, security builds trust within an organization, and it builds trust between consumers, and it's just really important that we try to make our applications as secure as humanly possible. So now we're going to actually talk about how to do this. First thing we're going to talk about is cross-site scripting. So cross-site scripting is basically code injection. It's a kind of injection attack where malicious scripts can be triggered client-side by an unsuspecting user. So people may actually trust the website that they're viewing, but if the website is vulnerable to cross-site scripting attacks, then it's possible that some other nasty person went in there and threw a JavaScript, little JavaScript script into the site, and it could be living somewhere in that application to infect or impact other users who unknowingly may reach it later. Usually these are client-side scripts. So as I mentioned, JavaScript is often what's primarily used for cross-site scripting attacks. And this can be bad for a number of reasons. It can be bad because it can allow session cookies to be compromised, which means the user session can be hijacked. And I feel like that tends to be the most obvious example. But it can also prompt an install script for some sort of sketchy program. And we're going to see an example of how that could happen. Or cross-site scripting can also spoof some content. So one particularly terrifying example for me was from OWASP, which is the Open Web Application Security Project. And we're going to talk about them a little bit in the next slide because they are fantastic. But they've essentially talked about an example of a cross-site scripting vulnerability on what could be a brochure site, like a pharmaceutical site, where you're not necessarily taking information from a user, but you're giving the user or consumer a lot of information. So a cross-site scripting vulnerability on something like a pharmaceutical site could actually allow an attacker to modify dosage information, resulting in an overdose. And that is terrifying. And I feel like it's one of those situations that we don't necessarily think about because there's no actual user data being stored. Oh, and there we go. Finally, the GIF is working. So the first type of cross-site scripting vulnerability we're going to talk about is a file upload cross-site scripting vulnerability. And this is exactly as it sounds. Essentially, a file containing some sort of malicious script is uploaded on a vulnerable site, and anyone who views that file can be affected. So let's say, for example, you have a site like, I don't know, LinkedIn that connects employers and potential hires. And this site doesn't necessarily check what kind of file is uploaded by the user when they upload their resume. the user could potentially upload some sort of malicious script or malware. And then if you have an employer who thinks, hey, this person looks like they could be a good fit, let's look at their resume. All of a sudden, they've downloaded or accessed that script. So we're going to see a demo example of this right now. There we go. So here I'm creating a dummy HTML file that's going to trigger a script with an alert that will just show the current user's cookie. We're not really doing anything malicious. We're just demonstrating that you can actually trigger some JavaScript that really is not supposed to be there. And this will demonstrate that there's a cross-site scripting vulnerability. So we've got our basic little HTML file, and now I'm going to upload it. And there's no problem because they're not checking that it is actually some sort of accessible, appropriate file. So now if I go to that particular file, there is my cookie. And that is demonstrating a cross-site scripting vulnerability. So now we're going to move on to stored cross-site scripting. And this is when the attack is stored somewhere in the application and the victim triggers it by accessing a page that renders whatever malicious script has been uploaded. So it lives on the server somehow in a database or a message forum or a comment field or any one of those, forms that may be stored in a server somewhere. And then the victim is presented the script and bad things happen. So we're going to see another demo outlining this. And again, we're going to see the alert script with the session cookie. So I'm storing this potentially malicious script as a little snippet. And in this context, snippet is sort of like a GitHub gist. And this gets stored to the web apps little database. And the form allows us to write this script. It doesn't strip out the actual functionality. So when I mouse over, there is the cookie again. And finally, reflected cross-site scripting attacks. So this is when the injected script isn't actually stored on the server. It's where the victim's lured into making a request to the vulnerable application, and the script is injected by, say, like a parameter of that request, and then returned immediately as part of the response. So stored cross-site scripting involves scripts that are delivered sometime later after the system was infected, and reflected cross-site scripting attacks happen right away for the user. So here we're going to see a simple example of a reflected cross-site scripting vulnerability. And one good example is with profile forms that don't validate or escape input strings. So here in the homepage URL input field, I'm just going to throw in a little JavaScript alert. So now if someone goes to look at the profile that I've created and says, hey, let's go see what her site's about, all of a sudden there is their cookie. So an example of cross-site scripting in real life is outlined in this HackerOne report. For those of you who haven't heard of HackerOne, it's a bug bounty program, and it's the one that we use with Shopify. And essentially what it allows people to do is ethical hackers and researchers are able to look at certain applications that have signed up for HackerOne, find vulnerabilities, and disclose them in reports that say, hey, we found this vulnerability, we think it does this, here are the steps that I took to recreate it, and take a look, and hopefully I should get some money from it. So this is one example of that kind of report, and this was for Uber, and this was on Uber's developer site. So Uber had like a README file that it was allowing people to submit suggestions to. And what happened is that you can load the README file, the README doc, and you get an SID cookie. So when you authenticate your session and you send a request with the appropriate cookie that you've already been assigned, and like you make a legitimate request, the response you get back gives you a new SID cookie. But then you can use this to load an edit page where you can submit suggested edits to the docs. Now the problem with this is that any attacker could add some random payload to the form that's being submitted as a suggestion to the Uber docs, and then this is submitted to some kind of administrator or whoever monitors the README documentation to decide whether the suggestion is actually valid. And why this is scary is that the injected script could actually auto-approve the suggestion, which is then accessible to anybody who goes to the developer.uber.com site and looks at the README docs, or it could actually potentially hijack other accounts as well. So this was a big issue. The ethical hacker received $7,500 for disclosing this vulnerability. And it's a really good example of a stored cross-site scripting attack in real life. And I really suggest you take a look at that report because it's very interesting. So how do we prevent this? The simple answer is to escape and sanitize all the things. So if you're taking input from a user, make sure that you are sanitizing that input to prevent users from submitting, JavaScript little snippets or other kind of malicious content, like we saw with the mouse over that was being submitted with that little snippet in the previous example. In PHP, this looks something like this escape attribute function. In Ruby on Rails, if you're a Rails developer, what's great is this is actually already handled as of Rails 3, so you don't have to worry about it. It's handled automatically. For those of you working in different languages or wanting to learn more, I really suggest you check out this Crosssite Scripting cheat sheet. Again, OWASP, who I mentioned before, the Open Web Application Security Project, they are fantastic. They have incredible resources, and this cheat sheet really gives you pretty much all the information you need to know in order to prevent cross-site scripting attacks on your web application. Another great resource is this code review guideline that they have also made public. And for those of you who are leading code reviews, this is a great way to kind of go through whatever code is being submitted with your project and make sure that the code being written and developed by your developers actually meets the guidelines that OWASP suggests. So next, we're going to talk about client state manipulation. So this happens when the server provides state information to a client, and then it's passed back as part of a request from the client, and the client is able to do nasty things with it. The lesson from client state manipulation that I'm going to say probably about 4 times over the course of the next 10 minutes while we discuss these slides is do not ever trust the client. Never, ever, ever, ever trust the client. And we're going to see examples of why. There are some really, really horrible things that can be done with client state manipulation. One very simple example that likely wouldn't happen nowadays because I think most people taking credit card information normally use some pre-existing software. But let's assume that some pizza place, like a mom and pop pizza shop down the street, built their own website and they're taking pizza orders. Now, let's assume that if you look at this little code snippet on the right-hand side here, let's assume that they have a submit order action and they're submitting this all with a GET request. But even if it was a post method, it would still be incredibly dangerous. So we see that, presumably at this point in the application, the user has gone through and selected what kind of pizza they'd like, and they meet this pizza order form page that says the total cost is $7.60. Are you sure you'd like to order? Then the user can either submit and continue to actually place their order, or they can go back and make some changes. Now, if you look at this, you also see that there's a hidden input type that handles the price. Now, the problem with this is that hidden input fields on a form are not actually hidden. So if you have some sort of malicious user who's like, I don't want to pay $7.60 for a large pizza, I want to pay $1.20, they could actually go inspect the document, inspect the page, change out the value to be $1.20, and then continue on with this process as though nothing had actually gone wrong. So all of this data would still be submitted to the server, and this poor mom and pop pizza shop would be out, a whole lot of money if this happened a whole bunch of times. So this is a very simple example. Again, we probably wouldn't see this as much nowadays because a lot of the time when you're taking credit card payments online, people are using more secured software. But in all honesty, I have actually seen this kind of thing in my life before Shopify while working at an agency and looking at other existing applications. I've seen people use PayPal buttons, and the PayPal buttons were actually, like the data associated with the PayPal button was being populated from an input field that was hidden, but not secured and not validated in any way. So even if you are using something like you think, hey, PayPal's trustworthy, it's still really easy to get around some of those, like, quote unquote security measures of using a piece of software like PayPal that seems like it should be secure. It's really difficult to actually pass any sensitive information to the client without it being manipulated or potentially manipulated in some way. The other issue we're going to talk about that can result from client state manipulation is privilege escalation. And this is a huge issue, and we're going to see an example of that coming up. But if the server isn't validating requests, then you can easily modify your existing account information to become an administrator. And that's bad for a whole bunch of reasons, and we're going to see that right now. So here I've logged in to my little site, and I'm just clicking around to see what I can do. Okay, so I see that I'm on the edit profile page, and there's that big long number. Okay, so what if I try to see what the structure of this, hey, look, if I go to code, I can see all the different files. And hey, look, there's an edit profile. And I can see all the code. And now if I search for admin, I can see all these if statements that hide certain admin functionality from me. But now that I actually see how the file is structured and how everything is actually submitted through the form, and that we're submitting it through save profile with the update value, I can actually go and just make myself an admin. So instead of edit profile, I'm going to save the profile, use that request, and I'm going to pass my action as update. And I'm also going to pass the isAdmin variable, and I'm going to set it to true parameter. Sorry, set the parameter to true. Now, if I sign out and then I sign back in, put in my username and password, just as I did before, all of a sudden I have this new fancy button that lets me manage the server because suddenly I'm an administrator. And I can reset the server, I can quit the server, I can edit any user's profile, and I did not have permission to do that. So how do we prevent this? Told you I'd say it a bunch of times, but not sending sensitive information back to the client is rule number one. If you're going to send information back to the client that is sensitive in nature, make sure you're sending it in some sort of signed state. You also don't want to make hidden data visible. And you don't want to use GET for sensitive information because that can be manipulated super easily. Post requests can also be manipulated really easily. And you can stop the request midway and look at what information is actually being sent. And so just don't assume that just because you're using a post request that you're actually more secure. Just make sure that your state is signed, or use something like a session ID that sends that to the client rather than the explicit data value. So for example, something like the $7.60 for a large pizza wouldn't actually be returned to the client as $7.60. It might be some long gobbledygook string of characters or numbers. And then that is stored in the database and used to look up what the actual value is for that price. If you don't sign everything, a signature can be generated by performing a legitimate transaction. So make sure that when you're talking about signed states, the entire transaction that you're sending back to the client is signed. An example of someone kind of getting around this whole signed state situation is, let's say you only sign the price. So you've associated some sort of signature with a price and you send it to the client, and you have to return the appropriate signature in order to make sure that the data that's being returned to you is legitimate. If you only sign the price, the attacker can actually go through the whole order process, get the signature for a super cheap item, and use that to complete the purchase of a more expensive item. Again, that would really only happen in situations where there's not very much security to begin with. But to err on the side of caution, make sure that you're actually associating signatures for data with the entire transaction so that someone can't say, hey, I'm paying $1.20 for this slice of pizza and I used the signature associated with, I don't know, pizza dip. That way you can actually see that the large pizza is associated with the $7.60. Cross-site request forgery. So this is when an attacker can actually use an HTTP request to access user information from another site. An example of this example is used quite often, although it's not as likely nowadays. Let's suppose that you have a user who's logged into an online banking application, and while they're logged into their bank, they also end up visiting some sort of sketchy website. And this website triggers some sort of attack that uses that user's authentication to perform some kind of malicious activity. Let's say moving $1,000 from the victim's bank account to the attacker's. This isn't super likely because I would think that most of our banks now actually use tokens, as we'll see in the next couple of slides. And there is more authentication because this would have happened to the bank already and it would have been disastrous. And so it's just, not as likely that it would happen again because it's been down that road. A more likely example of cross-site request forgery that I want to mention is something that could actually happen on a blogging site like, Blogger or WordPress. And not that these are susceptible to cross-site request forgeries, but let's just use those as an example. So let's say that you're using some sort of blogging site that is susceptible. And let's also assume the blogging app you use has some sort of request that takes the idea of the blog to delete. Like let's say you want to delete a blog and you pass that as a parameter to the request. And that triggers a delete function. So some attacker on their own blog could actually replace legitimate links on their blog with a request calling for the application to delete the blog of whoever's logged in and visiting the attacker's site. That is something that could very easily occur. And it's not necessarily something people often think about, but a lot of blogging applications do give you the ability to, within your template, say, get the current user's ID or the current user's blog ID. So that is a possibility if cross-site request forgery is not being prevented. So we know that servers really aren't particularly smart. They're not really smart enough to determine whether an action was intentional or whether it was, sent by some sketchy person on a different website. It really just sees the request and it performs it. And we're going to see an example of that right now. And this basically follows the example of the blogging app that I mentioned on the previous slide. So here I'm seeing what request is needed to trigger the delete snippet function. So I'm going to look at this. I see delete snippet, and then I pass an index value. Okay. So I'm going to copy that. Now I'm going to go to my profile, and I'm actually going to use that request URL as a little decoy for my profile icon. So whenever that icon loads, the server looks at the URL of the image at that delete request, but there is no image. But because it's looking for the image at that request, it's still actually calling the URL. So there we go, there it is. Now, if I go to my snippets, I did have one before, and suddenly they're all gone. So here's an example of a cross-site request forgery in real life, and this is from Harvest, the time tracking and invoicing app. They didn't have token validation for creating a category for any user. So if you already had a Harvest account, you could actually just create a category for any other user site, any other company that happened to be using this Harvest application, and name it to whatever you wanted. And again, there's the HackerOne report if you'd like to take a look at it. This is a less severe report than the cross-site scripting attack that we saw with Uber. So as a result, this ethical hacker was paid something like $100 because Harvest didn't consider this a huge issue, but it is an example of a cross-site request forgery attack. So how do we prevent this? Tokens. Tokens are your best friend. And this is what banks use. Banks really use this tokenization to authenticate a user, because it's actually really hard to spoof some random series of numbers and characters. It's difficult to do. So the site requires a special token before it actually performs any data altering operations. And then it's submitted with the request and validated by the victim site. The other thing you can do is validate origin headers submitted with the request. And OWASP has another cheat sheet for this that I suggest you check out, just like the Crosssite Scripting cheat sheet. And they have a great example of how to basically run through all of the different preventative measures. Finally, we're going to talk about SQL injection. So I figure any of you who read XKCD have probably seen this comic strip, and it's pretty great. It's a really good example of SQL injection. Another name for SQL injection is command injection vulnerabilities. So the end user supplied input is inserted into a query or a command that causes the command interpreter to misinterpret it. So we're going to see an example of this right now. So I can tell this is some kind of form. And this is actually on a CTF learning application that I'll talk about in a little bit. So I see this input. I know it's some sort of form. I don't exactly know what it does. So I'm just going to throw in some dummy text, hoping it'll tell me something. It doesn't really show me anything. But I can see that it submits something somewhere. There's a submit button, there's the form action. So it must go somewhere, it's a form. So I'm going to throw in this potentially malicious breaking SQL query. There we go. So what happened is I actually broke the database query. Broke is sort of an inaccurate description, but I essentially finished off the query saying, 1 always equals 1, so that's always going to result true. And as a result, the database actually threw back all of the data that it contained, and I was able to actually access all of that data. So that just means that their SQL queries weren't being sanitized. Sometimes attackers can give wonky input. So that's when I say breaking, there's a couple ways that you can quote unquote break a query. One is to really just, give an input, give weird input that just totally breaks the request and hopefully see some error messages that pop up on the screen so you can kind of get an idea of how the application is configured. And then you can also submit queries that complete a legitimate request, as we just saw with the 1 equals 1, or for example here, month equals 0, and you finish off that query, and then you can say drop table X. And here, if you do this, because there is presumably no month 0, the first half of that query, whatever it was supposed to do, doesn't actually do anything. So that finishes. It says, okay, well, I have nothing to do. I have nothing to return. Month, there's no 0 month. So let's go on to the next instruction, dropping table X. That is dangerous, because now you've just lost an entire database table. It can also result in information leakage, as we just saw in that last demo. So here's an example of that, selecting star from X where user ID equals this and order month equals 0 or 1 equals 1. 1 equals 1 will always be true, so that will be evaluated. And you can say the order month equals 0 and 1 equals 0. And then you can select all of the card holders, numbers, expiration months, expiration years from credit cards, and that will actually be joined with the lack of data you received from the previous query. So you won't actually get any customer orders in that result, but because they specified that union, the database will still retrieve the information from the credit cards table. Here's an example of SQL injection in real life. And this actually happened in 2014. Bell Canada, a big company here in Canada, was attacked by a hacking collective called Null Crew, and they used an error-based SQLi injection attack. So this actually ended up in basically leaking over 40,000 records from one of Bell's subdomains. It was all through a vulnerability in their password recovery page. And Troy Hunt, if you've heard of him, he's basically a security legend. He's responsible for the super helpful site Have I Been Pwned, which tells you when you enter your email address, you can see whether that email has been involved in any sort of security breach. His blog's also full of tutorials and explanations and reports. It's a really great learning resource. And he actually steps through this entire attack and recreates it with his own ASP password recovery page. So I really suggest you check that out if you have any interest in this particular attack vector. It was terrifying and interesting at the same time. So how do you prevent SQL injection attacks? Prepared statements and bind variables. So these placeholders are guaranteed to be data, and I'm sure a lot of you have seen them if you've worked in certain frameworks like Laravel with PHP has them. So you put placeholders where you're going to actually put or submit something that should always be considered data. So for example, we see here user ID equals question mark. So that question mark will always be data. It cannot be essentially run as some sort of query, and you don't have to worry about it being passed to the database. Even if someone passed in something like 1 = 1 semicolon drop table X, that would still just be seen as data, and presumably your database would be set up so that it could only take integers for the user ID, and it would just throw out an error saying, hey, that's not an integer. Whitelisting. Whitelisting also works, specifying what the input should look like and not allowing input that doesn't match a pattern. And that's kind of similar to the prepared statements and bind variables. And it essentially, again, just tries to make sure that whatever is being passed to the application is what it says it is. So, you set up some sort of pattern that really wouldn't match some sort of SQL query. It has to be data, it has to be an integer or a float or a string or whatever else. Some things that don't work well that some people have implemented, and it's really not particularly secure. Blacklisting doesn't work particularly well. So, if you're looking for dangerous characters like like a single quote mark, that could conflict with functional requirements. So for example, my landlord's name is O'Brien, and if you were blacklisting that single quote, then all of a sudden he cannot be entered in a database anywhere. Blacklisting also doesn't actually prevent numeric parameter attacks, and attackers can really just use JavaScript or some sort of encoding to specify characters that are blacklisted. And you basically have to go through all of the different possible encodings to blacklist those, and it's just kind of messy. So it's just better to err on the side of caution and not rely on blacklisting in that way. Escaping doesn't actually guard against numeric parameters. So that's really not the best approach either. And then sometimes people talk about stored procedures, and those can actually still be performed to use malicious, or they can be used to perform malicious attacks, because you can just modify the structure of the statement. So really, it's best to stick with prepared statements and bind variables and whitelisting, and kind of avoid the stuff that could work but still has the potential for vulnerability. So now we're going to talk about how to keep learning. There are some incredible books for web application security and web hacking. I really suggest you check out the Web Hacking 101 ebook. It's written by my coworker Peter, who he literally wrote the book on web hacking. And the foreword for this book was written by the guys who founded HackerOne, which is our bug bounty program as well. And it's just an invaluable resource. It is, application developer, and it's available online and it's really affordable. So I would definitely recommend that one. Another great book is the Web Application Hacker's Handbook. This is another excellent resource. It's been used from certain courses that I've seen as kind of like the textbook for students. And then finally, Foundations of Security, What Every Programmer Needs to Know. This textbook was written by the professors who teach the Security Foundations course for Stanford's Advanced Computer Security Certificate. And it's also a great resource. It's very easy to see how the attack vectors they discuss can be applied to everyday web application development. And it's really user-friendly. Podcasts. So OWASP they actually put out a podcast. So I suggest you take a look at that, because they talk about a whole bunch of different issues, not just tutorials and stuff, but also, recent attacks and kind of like cybersecurity in the news. The Cyberwire is similar. And then finally, Smashing Security. I listen to Smashing Security every single week. It is less about how to avoid certain vulnerabilities, and not necessarily specific to web security, but they do talk about any major breach that has popped up in the news. And the two hosts have been in the industry for years and years and years, and they just have a great rapport with each other. Like, I've burst out laughing on the bus listening to them. They're really great. And then finally, courses. So I'm really only talking about these courses because I have experience with them. I've enrolled in the Stanford's Advanced Computer Security Certificate, and it's great for anyone who doesn't necessarily want to, go back to school in person and take a course in real life with a professor. All of their lectures are recorded online and readily available. Again, the professors for this wrote the Foundations of Security book, and they cover everything from security foundations to web security to mobile security to network security. There's kind of everything you could possibly need in that particular certificate program. For anybody in Canada who knows of Ryerson University or in the States, they also offer an online-only option for their security certificate program. And I'm also in this. I'm also a student in this particular program, and it's great. The professors are actual computer science professors at the university, and you submit labs and assignments, and they actually review and give you feedback for a number of different courses: network security, cryptography, digital forensics, mobile security. It's a really wonderful resource as well. And again, both of these are offered online. You don't actually have to be there in person, but they are not free. So there is tuition associated with each. They are about the same price when you factor in the Canadian and American exchange rate, but as I said, they're not free. Coursera, on the other hand, actually has a number of free courses available just right now. You could go after this webinar and look them up. And a lot of them are produced by actual security experts or professors, and a whole range of different topics. So they are a great resource as well. Now, because we're getting up to Black Friday and Cyber Monday, for anyone who is interested in checking out some InfoSec software or books and stuff like that, this guy on Twitter came up with an entire list of all the deals coming up for this coming weekend. And again, I mean, it's a pay spin, so I've taken a look at it. There's nothing sketchy going on there. He just happens to list all of these really great deals for certain software, like I can't remember the name of the site right now, but it essentially lets you see all of the Internet of Things devices that are currently connected to networks, and it's used a lot in IoT hacking classes. So if you're interested in that, their software is up there. And there are also some really great courses. There are some online programs, sort of like Udemy, but specifically for security, and they're having a big sale right now. So instead of being like $100 a month to access their entire catalog, it's $30 a month. So if you're interested, take a look at that. There are some great educational resources there. Now, practicing, I think, is probably one of the most important things you can do. CTFs, for those of you who haven't heard of a CTF, it's short for capture the flag. And basically what happens is either by yourself or with a team, you are given vulnerable web applications or really any kind of software, and you have to look for certain flags. So for example, it could be something like finding a Crosssite Scripting vulnerability in a web app, or it could be doing reverse engineering on a particular piece of software that you've been given by the organizers. And then you actually look through, whatever your particular assignment is, and you try to find this little flag, and they can be kind of structured in a number of different ways. But once you found that, you know that you found a vulnerability in that application. There are a lot of websites for practicing those. Where you saw those demos that I was doing earlier, that is actually an app that was developed by the security team at Google to help people learn about web security. And it is an amazing resource and a lot of fun to work through on your own as well. So that's a great place to practice. Shelter Labs is sort of like a social network style CTF. So you create an account, you can go through and find vulnerabilities on their site. And then there's this website as well, where there's a collection of 22 different hacking sites, CTFs, and war games. So even if you don't necessarily live in an area where you can readily, go participate in a CTF with a team or with your coworkers or with your friends or whatever, there are a lot of resources online, and they're a really, really great way to learn. My first CTF, I learned so much from the people that I was working with. It was probably more that I learned in 2 days just from working alongside them and trying to find these vulnerabilities than I could have from spending 2 days reading all the books in the world. So having that practical hands-on experience is really, really great. So thank you. That is the presentation. So thank you all so much again for joining. And for those of you joining in from the United States, happy Thanksgiving, and hope everyone has a great rest of their day and a wonderful weekend.